Good day, everyone. Today, I'm presenting a assembly project that benchmarks CPU performance using a polynomial stress test. The goal is to measure how efficiently a CPU handles uh, repeated arithmetic operations. So, let me present the code and explain how it works for the questions given to us. So, let's start. We're going to go through the here, we have included the A132 library to access helper functions like printing, delays, and time measurement. Next, we have defined the coefficients of a polynomial according to the birth dates of our group mates. So the first one, A will be 25, B will be 12, C will be 21, and D will be 26. So next, here we have declared the loop input variable, which is 9, and a running total sum, and a temporary variable x. Okay, so next, these variables will store the start time, end time, and total elapsed time of the loop in milliseconds. Okay, so here we have a few messages that is going to read out these sentences. Like we have welcome to CPU benchmark program, benchmark CPU time using equation. So the equation that's given to us in this question, when we have included our group mates birth dates as the variable as the input, a is equals to 25 and stuff. The equation that we get is 25x cubed plus 12x squared plus 21x plus 26. Okay, so next we are going to go here. The program begins at the main procedure. First, the screen is cleared, and then we have printing the welcome message. Next, let's go here. We are displaying the polynomial equation being used in the benchmarking and along with the explanation of the coefficients. Next, the user is asked to enter the number of iterations which is saved into the n variable for the loop. So, how many times the loop have to be repeated is based on the n value. Next, we're going here, which we inform the user that the benchmarking process is starting. Next, initialize. We initialize the loop counter ECX to 1. Then we reset the total sum to 0 and record the start time. Okay, so this calc loop will be checking if the loop has finished or has finished. And then if ECX is more than n, it exits the loop. Okay, so here we are going to save the current x value same as ECX. Okay, here x squared, we are going to calculate x squared and store it in ESI. For x cubed, we are going to calculate x cubed and store it in EBI. Next, we are going to compute the first term of the polynomial. Then, uh, we are going to compute the second term of and then add it to the total of the term, total of it. Here, we are going to calculate the third term and add it to the total also. And here we are going to add the constant term d. Okay, here to the delay, we are going to add a small delay, which is 5 milliseconds delay to simulate CPU load. Hmm. Here, uh, we are going to add the calculated value of y to the running total sum. And here, we are going to increase the loop counter and repeat until the ECX is more than 9. Okay, here next to end the loop. Once the loop ends, the second time is recorded. And here, we are going to calculate the total execution time by subtracting start time from end time. Okay. Here to display the results, we are going to start the result output selection. Here, we are going to display the start time. Here we will display the end time. Okay. Here we will display the time difference of the execution time. The next will be for to display the total sum of polynomial results. Okay, here we will ask the user if they want to continue or exit. So we can also add like optional logic for looping can be added, but we choose not to. And finally, at this part, the program exit screen. So let's run the program and see the outputs. We will build the solution first. Okay, it's one succeeded. Let's debug. First, okay, we are going to enter the number of looping, which is going to be 50. Okay, we got the first capture execution time in millisecond, which is 2661213, and second capture of execution time in millisecond, which is 2661985. And the difference in the execution time in milliseconds is 772. And the value of sum from the stress test polynomial is 41180,800. Next, we are going to do input number of 100. Okay, this is the result we got. Number of n is 200. Okay, we got the result. Okay, again, the number of looping we are going to get is 500. Next value we are going to key in is 700. Okay, we got the results. Lastly, the number we are going to key in is 1000. Okay. So the final output we got is first capture execution time in millisecond is 292625, and second capture is 2941608, and different execution time in millisecond will be 15483, and value of sum is 165503636. Okay, so we're going to exit. That's it from us. Thank you.